Hello everyone, in this tutorial we are going to be making a simple physics-based game using Wade. So the first thing we need to do is open our browser and navigate to clockworkchili.com. Okay, once we're there we are going to click Get Started Now, and this should open our editor. So now we're in our editor, I'm just going to click Skip Tutorials, New Project, and I'm going to call it Angry Cannon. And we click Create Project. So I said this is going to be a physics-based game, which means we need to use the physics plugin for the editor. So I'm just going to log in up here by clicking the smiley face. Okay. Password login. Please wait. And there we go, we're logged in. So now, if I go up here, we see this icon, which is of an atom. We just click on that, and it says, this is going to add the Wade physics plugin. So then we click OK. We'll see down here we have one more file, wade.physics.js, and it has automatically been added to the scripts. So that is all our physics all set up and ready to go. Now, like other projects, we want some art in here, so I'm just going to go and drag in these art assets. You'll be able to find most of these on the shop, or you can use your own, whatever you fancy. Okay, so the next thing we're going to do is just a little bit of project management. We're going to set up our project at 1280 by 720 resolution. And we're just going to lock it to that. We'll set the default layer to 10. And let's see, I think that should suffice for now. I'm just going to go ahead and save. Yes, so the first thing I'm going to do is drag my background into the project. Excellent. I'm going to name it background. And I'm just going to set its position to 0, 0. So that just gives us something to look at. Now, one last thing we need to do actually that I've just remembered, we need to click on app.js. And in here, we need to do two things. We need to do wade.physics.enable pre-collision events. This just means we can handle the collisions for the physics engine manually. We can override them with our own behavior if we need to. The next thing we need to do is change the gravity. So I'm just going to set the gravity on the y-axis to about 750. I think that should be okay. Now we're just going to reselect our background and move it to layer 15 just to make sure it's behind everything else. And I think we'll run the program now just to make sure everything's working okay. So yeah, here's our background. It takes up the whole screen. Excellent. Now, of course, we called this game Angry Cannon, so we need a cannon. So I'm just going to drag in these two images. This one is the carriage for the cannon. I'll just rename that carriage. And we've got the cannon barrel itself, which we'll just drag on top, and we'll just name that cannon barrel. That should be quite simple. Now the next thing we need to do though is rotate the cannon. We want the ability to rotate the barrel, and we're going to do that on mouse down and on mouse move. So we click on our background layer, and we are going to go to our on-mouse down function. So the first thing we need to do is get a reference to the cannon. So we can do that by var cannon equals wade.getSceneObject, and it's cannon barrel because it's the barrel of the cannon that we want. Excellent. So now we need to rotate it. So to do that we need to get the displacement between where we've clicked the mouse and the position of the cannon. So var displacement is equal to wade.vec2.subtract data.screen position, so that's the position of the mouse click, and then cannon.getPosition. Excellent, so that gives us a vector between the mouse click and the cannon. And now we need the angle of that, so we do var angle equals math.atan2. Then we need to pass the y value of the displacement in, and then the x value. Okay, so hopefully, if that has worked, we'll get the angle the cannon needs to be rotated to. So all we need to do now is cannon.set rotation, and we'll pass in angle. Now we're just going to run this to see if it works or not. So I'm going to click, and indeed the barrel does rotate. Now notice on mouse move doesn't work yet. That's because we are in on mouse down, and that's not what we need to do. So we don't really want to write this code twice, so instead we are going to go to on add to scene. We are going to write this dot listen for, so we're adding an event to listen for, on mouse move. And then we are simply going to say this dot on mouse move is equal to this dot on mouse down. So we don't have to write the function again, we're just copying it into there. So we'll try and run our code here. Now unfortunately I've not actually got the mouse clicked, and the reason for that is of course because in our on mouse down function we're assuming it was a mouse click and we're not doing anything when the mouse is released or anything like that. So we're just going to add a condition if Wade.is mouse down. If that's true, this will work. If not, it won't. Oh, let's just neaten up that indentation and save there and run. So now when I hold the mouse down, the cannon moves. When I don't, nothing happens. So we've got some basic primitive controls for our cannon. That's very, very nice. Now to do the next bit, we need to download a behavior. So I've already logged in. I'm going to go to the forum for now, even though it's not exactly where I need to be. I'm just going to navigate to here. This will be changed at some point. You'll be able to go directly to the main website. We're going to click on learning. Sorry, no, we're not. We're going to click on projects. Getting a little bit lost. And we are going to find the timer bar demo. And this has got the simple bar behavior, so we'll just click on it. And here we see a lot of craziness going on. It's just a demonstration of how the behavior can be used. And I'm going to download this. So if I just scroll up here and click download, timer bar demo, show in folder. Let's just extract all of that. And then we need to take out of it the simplebar.js file. So we'll just go back to here, open that again, and I'm just going to drag that in here. Excellent. Now we need to add that to our scripts. So we go simplebar.js add. And that's all we need to do to add the behavior. So now we're going to add a new scene object. We're going to call it bar. And this is going to go right at the top, and this is going to indicate the power of the cannon, because we're going to change how far the cannonball goes based on how long you hold the mouse down. So we need a bar to indicate that, so I'm just going to make it roughly bar shaped. That should do. And I'll position it a bit further up. Oop, too far. That should do. So we're going to go ahead and save that. Then we are going to go to behaviors, simple bar, add. So we've got the behavior. We want the bar to start off empty, so that's all okay. The direction is correct, and a red bar. I think we'll have a bluish background color, maybe something like that. I think that'll go okay. 55 E, and we'll set that to layer 10. So let's just run this to see what that looks like. Okay, the bar's fully blue at the moment. If we set the current value to say 30, it gets filled with red. Excellent. Just put that back to 0. So now we need a fire button. So I'm just going to drag in this button image as a new scene object. I'm just going to set its name to button and its position to 0, and we'll try -250. Oh, that worked out well. Excellent. So now we go to sprites, and we are going to add a new text sprite to this. Okay, we're going to set it to 32 pixels, and the text is going to be hold to fire. I'm going to set the color to red. I'm going to align it to center, and it looks a bit high, so we'll go with, 10 on the Y offset. That looks good. Excellent. So now we've got our cool button, but of course the button doesn't do anything at the moment. So let's go to the button properties. And we're going to add 2 custom properties to this. So I'm going to append one that's called timer active. It's going to be a flag, and for the moment it'll be false. We append another one called power, and we set that to 0. And then we save this. Now, an important thing to note, if I just play this, if we click here, you'll notice mousing over the button, the cannon still moves. We don't really want to do that, so what we're going to do is we're going to go to functions, add on mouse move, and we're going to set return true. All this does is when the mouse moves over there, it will return true, so the event will not be captured by the background. So there we go. It stops the cannon moving when you're over the button. Very nice. So I believe we need to go to on mouse down, and all we need to do here is set this dot timer active to true and return true. Okay. Now the main work of this function will be in on update, so we need to go in here. Excellent. Now a lot of things have to happen in here. So first of all, we need to get the timer bar. So if this dot timer active, we need to do our work. So we get a reference to the bar, way.get scene object bar, and I think I might actually get the behavior specifically. I think it'll work better in this case. So what we want to do here is we want to increment the bar and then set the value of the bar to our power value that we created just before. So we do bar.increment. By default this is 1 if you don't pass in a parameter. And of course we could change that if we wanted it to be faster or slower, but this will do for now. And then we're going to do this dot power equals bar dot current value. Excellent, and I think that's all we need to do in here. Just thinking about that. Yes, it looks quite nice. So the final one, of course, is when you fire the cannon, and that'll happen on mouse up. So let me just go to on mouse up. So the first thing we do is set our flag to false. Timer active equals false. Then we need to call a fire function for cannon. Now the fire function doesn't exist yet, but we're still going to set it up. So we need to get the cannon. In fact, do we need to get the cannon, or can we just use it once? I think we're okay to do it like this. So wait, get scene object, cannon barrel. Excellent. Then we're going to call fire, which doesn't exist yet, so this won't work yet. And we need to pass a value into that. We're going to pass an object with a magnitude parameter, and we're going to set that to this dot power. And I think that is all we need to do in here. I could be wrong, but it looks okay for now. So let's just try that. Let's just run and see what happens. If I hold to fire and I leave go, very close, the power stays at full. So that is the other thing we need to do. We need to do way.get scene object. We need to get the bar. We need to get the behavior. And we're just going to do set 0, which is a function I added that just sets the value to 0. So we run again, hold fire, and we see the bar goes back to 0. So that's the behavior we want. Excellent. Now, of course, the next stage is we need to add a cannonball because we need to fire something out of our cannon. So let's go ahead and add that in to our project. Now I've got a cannonball image. I'll just drag that in and I'll rename it ball. I'm going to make this a template object because we are going to make use of the clone feature. And I'm also going to make it a physics object. And I think the default values here should be good, but we're going to edit the physics shape. We're going to select circle and make it a bit smaller. Just dragging all these in. There we go. And apply that. So now we have our cannonball. The next thing we need to do is fire. So we select our cannon barrel, not the carriage, be careful of that. We go to functions, and we need to add fire. This is the only function this is going to have. Okay. So we need to clone the cannonball first. Var ball equals way.get scene object ball. Very, very simple. And then we're just going to straight away add it to the scene. We'll change its position velocity in a bit. So Wade, add scene object, ball, true. Okay, now what we need to do is set up where the ball starts and the force at which it is fired. Excuse me. So the first thing we need to do is offset it from the barrel, and I've already done the measurement, so I know it's 200 pixels. So assuming the cannon was facing the way it is, we would want to displace the ball by 200 on the X and 0 on the Y. That's all good. Now, of course, we can rotate this displacement, which is what we are going to do in a minute. So we need to get the angle of the cannon to do that. So I'm going to say var rotation equals this.get rotation. Very simple. And I'm also going to quickly set up a force variable, actually. So the force I want this to come out with is going to be that, and about 100. So it'll go slightly upwards, but mainly sideways. And you'll remember we passed in a magnitude parameter to this. So we times this by data.magnitude. And we do that for y as well. Although it's less important. We could probably ignore it for y, but I'll go ahead and include it there. And I'm going to save that. So what we need to do is rotate the displacement and force vectors by our angle. So Wade dot vec2 dot rotate in place is the function we will use for this. And then we just pass in the displacement and the rotation. And we can do that as well for our force. So I'll just go ahead and do that. Force is there, excellent. And now we just need to set up the position and apply the force. So the ball position is going to be equal to wade.vec2.add the position of the cannon, so this.get position, and the displacement vector. So we just do displacement. Excellent, that should be right. Now we also need to apply a force to the physics object, so we get the behavior of the ball, and we apply force, and we just pass in our force object. Now I think, for now, that is everything we need. So let's have a go. Let's run, let's hold to fire. Nothing happens. Warning, a scene object named ball is already present in the scene. Oh, I've made a mistake here, and the reason for that is I didn't clone it. Missed the clone command, so we'll just play again. Hold fire. Whoa! And it freezes, that's good. Let me just do a quick bit of debugging here. Cannot read prod body of undefined. Okay, I'm probably doing one of these rotations wrong, or passing in a parameter. Set position is a good candidate for this to be wrong. Let's have a look. There we go. This.get position, I've missed the brackets off. I was passing in a reference rather than the actual function. So let's go. There we go, we've got cannonballs. Excellent. Now at the moment they just disappear off the screen, but you do notice the longer we hold them down, the faster they go. Very, very nice. So we can fire a cannon, but it's a bit, well, it's not really that interesting if we don't have any targets, is it? So what we're going to do is, first of all, add the ground. And this is just going to be really simple. We add a new scene object. We call it ground. We're going to give it a property called isGround, which will come in handy in a minute. And we'll set that to true. And we just need to drag it down to the ground level, make it a bit bigger. That should be okay. We go to sprites, we set it invisible, and then we add it as a physics object. Now we need to set static object to true and mass to 0. And we'll just save and run this again. So now, when we fire, the cannonball should collide with the ground. And you'll notice the cannonball just stays there forever, and we don't really want to build up a lot of cannonballs. So I'm just going to go to the cannonball, sprites, and I'm going to say new animation. So we add our explosion image. We name the animation explode. The cells should be 6 and 5, and I'll go with the speed of about 40. So I just click active. Good, that looks okay. Now on animation end, so on the end of the explosion, we want to remove this from scene. So this dot, sorry, not this, Wade dot remove scene object, and we pass in this. So that's simple enough, but we're never calling our explosion, and we're going to do that in the cannon. So after everything else has been done, we're going to do set timeout, function, and in here we'll just actually do it for 3 seconds. We need to do ball dot get sprite dot play animation explode. So we're just going to test that and make sure it works. Okay, let's watch it. And there we go, it explodes. That's working well. Now, we're going to go ahead and add our barrels, which should be quite straightforward. So I'm just going to add a barrel here. Okay, I think I want to make it a bit smaller than that, and I'm going to change the position as well. So we'll set that to barrel. That's quite close to 200. I want to make it smaller. It looks a bit too big. So I'll go to 310, shrink that even more. Does that look okay? I think that looks okay. So in the barrel, we need to add a physics object again. And this should be all good. Now we're going to initially set it to static. This is just to stop it moving around in weird ways if we don't align the barrels perfectly. And mass 0. So, oops, I just added a second collision object there. Let's just remove that. There we go. We go to functions. We need to add an on pre-collision function. Now, we enabled this before. This is so that when a collision is detected, we do this dot get behavior dot mass equals 1. So we're just making it so the barrel can move. This may not be necessary after the physics engine has been implemented a bit further. At the moment, it's still kind of in an alpha beta stage, but it works pretty well. So we're going to leave it like this for now. So I think that's all we need to do right now with this barrel. I don't think there's anything I'm missing. Let's just have a look. Are we missing anything? I really don't think we are. So I think we're just going to duplicate this. So you can use the duplicate button or Control D. There we go. I'm going to go to properties and we'll increment the position by 100 on X. And that worked out very well, so we're just going to do it a few more times. And we'll go to 500. And we're going to do the same, but now we need to go up by 100. There we go. And we're going to keep doing this. Really, I should have made sure that the cannonball can actually collide with this before I went ahead and positioned everything, but we might be alright. We'll hope we're alright. 300, 110, so I'm just going ahead, duplicating everything. Should be fairly obvious the pattern I'm using here. And there we go, we've got a big stack of barrels, so we're just going to save this, run it, and we're going to fire and pray that everything works. That looked okay. Ooh, barrels are getting blasted to bits. So that's quite fun, that worked well. Now, we need one final thing in our game, which is an objective, and that is what this star is for. So we're just going to drag the star in, going to drag it down, and we need to call it star. We need to go to behaviors, and we need to add a physics object again. Just moving that around a bit. And I will go to edit physics shape, and we're just going to drag that to the corners of the star. It's obviously not perfect, but it's easily good enough for what we're doing. Add an extra point there. And there we go. So now we've got our star with physics behavior. I'm going to set that to static as well and do the same trick with the on pre-collision function. So we just go here, on pre-collision. Right, we need to do a few more things in here, actually, thinking about it. Quite a lot more things. So, first of all, this dot get behavior. Oops, can't spell. Behavior. Dot mass equals, let's make it lighter, actually, 0.5. Now the star needs to do two things. The goal is to get the star on the ground. So when the star touches the ground, which we can test for in here, we are going to reload the whole scene. So if data.object.isGround, so if we're colliding with the ground, we want to do way.clearScene, and we also want to reload the scene. So we're going to go to app briefly. We're going to copy our load scene function in here, and we are going to paste that just after this. Excellent. So I think we should test this out first before we add our final feature. Or should we? No, we'll go ahead and add the final part. We need to, in the onUpdate function for this, make sure that the star doesn't get blasted off the right of the screen, because that's not very visually pleasing if you can't see what the objective is. So we're going to do if this.getPosition .x is greater than way.getScreenWidth over 2. Oops, there we go. Then of course we've gone off the right of the screen, and likewise we need to check for the left of the screen as well. So we'll just do this, reverse the sign, and make that minus. Okay, so if it goes off the screen, we need to set the position to the far edge that it's allowed, and we need to flip the velocity. So this dot set position x is going to be equal to way.getScreenWidth over 2, and the y position won't change. Now this is the same for both of them, so I can just copy and paste this, with the exception of I need to flip the sign here of way.getScreenWidth once again. We also need to change the velocity, so this dot set velocity, velocity, and we're going to pass in an object into this because that's what velocity accepts. So we need an x parameter and a y. Now the y velocity is going to remain unchanged, so we just do this dot get velocity. Wow, really can't type today. Dot y. Now x is going to be a bit different. We need to do this dot get velocity dot x times -1. And I think that looks okay. Yes. So we're just going to copy that into here. Really, we could probably do this in one set of if statement, but can't think right now. So we'll just try it like this and see if it works. So let's run our game. So when the star hits the ground, hopefully we will get a game over thing. Yes, we got the Wade clear scene happened. So you could obviously easily implement a congratulations, you finished, do you want to play again? But for now, I think that is a very good time to end this tutorial. It looks very good. Of course, this will work on your browser, it will work on phone, and actually I should mention that feature because it's brand new. If we go to here, download package, and click Android app, it will build into an Android app in the cloud, and then we can download it, and it's really easy to put it onto your phone. So hopefully guys, you've enjoyed this tutorial and you like the game. Thanks for watching.